Alright guys, so this video is about the general information of carbohydrate. Well, carbohydrate, as you know it, carb, is your sugar. The fancy scientific name is saccharide. This have a general formula of CxH2OY. And you might have known it, sugar is used for energy. So let's take a quick look at an example of a carbohydrate. Glucose. Glucose formula is C6H12O6. Again, you do not need to be able to draw these. They are available in the data booklet, section 34. However, I'm drawing out the straight ring monosaccharide so that you can understand how the structure works. So let's look at glucose. You have C6, that means there is 6 carbon connect to each other. A sugar will have a aldehyde or ketose group. And unlike fat, sugar have 2 or more of the OH group, which making it soluble in water. Alright, in this case you have 6 OH groups, so I'm just going to draw a few, these 6 here. So once you get all the important feature of the molecule done, you can just fill up the rest of the bond, the required bond, with H. Remember, C require 4 bond. In solution, when a sugar is in solution, it actually doesn't take the straight form. It actually takes something called ring form. And how the ring form works is that, let's say if you were to draw this as a proper Lewis structure, this oxygen will have extra lone pair, making it electron rich. This carbon is partially positive because this oxygen is going to steal most of its carbon away, most of the electron away from this carbon. So if you remember from organic chemistry chapter, it's going to be a nucleophilic attack between this oxygen and this carbon, looping this whole molecule around, making it into a ring, a 6-member ring. 6-member, so it's going to be a hexagon. Now one of the corner of the ring is going to be an oxygen because of this oxygen attacking. There's going to be the CH2OH right next to this, connected to this particular carbon. Then you got 1 OH, 2 OH, 3 OH. And then when this attack happen, obviously this double bond will break. Oxygen is going to grab another H plus, forming another OH over here. So you OH here, an OH here, here. And then of course you can fill the rest of the bond with H. Now you don't have to know how to draw the structure, but the point here is that this whole molecule loops around and it becomes a ring. And this one ring is going to be called a monosaccharide. Again, mono means 1. In a second, I'm going to show how 2 monosaccharide will join to each other and become disaccharide, which means 2 saccharide. And when you have 2 or more saccharide, you are going to be poly. Poly means many. So many saccharide. With 1 hydrogen, 1 OH group down, 1 up, 1 down, and 1 up. Now, if these 2 beta glucose wanting to join together, they will between these 2 atoms, and that will produce an HOH, or water, and this is called a condensation reaction. Now, once the condensation reaction happen, we still got the 2 ring of sugar joining together. However, something happened. The second molecule, in order to be close, it will have to flip. And when this molecule flip, this O used to be here, is going to be flipped downward over here. Then there's the CH2OH group, instead of being up here, is being flipped down towards CH2OH being down here. Now the first molecules stay exactly the same, just CH2OH group here. Okay, now what does the bond look like? Well, we have an oxygen left here, so we're going to have a bond to an oxygen. There's no oxygen left over here, so that is just a straight connection. I can draw the other OH group just to be careful. So the first beta glucose stayed the same, the OH group the same. The second one though, I've got to be careful. Now the H is down here, this H is up, so that means it's going to be pointing down. There's probably an H over here. This OH group used to point up, that means now it's pointing down into the underneath the ring. An H group up here, OH group now being, since it used to be down, now it's being flipped up, and this OH group used to be up, now it is down. So the molecule is completely flipped.